This lesson is on the fundamental theorem of calculus with use substitution, and in our previous lesson we just went over the fundamental theorem of calculus, but none of the problems had use substitution in them, and so I wanted to show you how it worked when you have that. So let's look at this example. So our first example, we have a u sub problem, and our u will be the x squared plus 1, because part of the derivative of x squared is x, and it's in the problem already. So we have x squared plus 1, and then the derivative of u is du dx, and then we take the derivative of the x squared and get 2x, derivative of 1 is 0. Since the problem doesn't have the 2, we have to divide and get 1/2. So 1/2 du will equal x dx, multiplying by that dx on both sides. Okay, so now I look and I have x dx in the problem here, and I'm going to replace that with 1/2 du. Okay, so we replace that with 1/2 du. This was our u, so we have u cubed. Now, the extra step for doing the fundamental theorem here is that we need to change our limits. Up here, the 0 and the 1 are limits that correspond to this when the variable is x. But now our variable is u. Everything has changed to u. So these limits aren't exactly what they're not going to work exactly the same way. So I need to turn this 0 and the 1 into u limits. And the way you do that is just plug them in for the x over here. So I plug them in for this x. Looking at that whole piece right there, what comes out will be our u limits. So if I plug in 0, 0 squared plus 1 is 1. So the 0 limit becomes a 1. Then I plug in the 1. 1 squared plus 1 is 2, so the 1 limit becomes a 2. And so that is the difference in having a u sub fundamental theorem problem. Now, from here, you actually have two options on how to solve that, and so I'm going to separate them on my paper so that you can see whichever one you like to do best. I don't care, as long as you do one of them correctly. So here we're going to take the antiderivative of u and have u to the 4th, which would put a 1/4 in front, and I had the 1/2 in front. So that's really going to become 1/8. And I'm evaluating from our u limits 1 to 2. I'm not changing or plugging my x's back in. So I'm going to go ahead and change that 1/2 times 1/4 and make that 1/8. Okay, and again, I'm keeping the u limits because I'm keeping the variable u, and all I have to do here is plug in, like I use the fundamental theorem. So 1/8 2 to the 4th minus 1/8 1 to the 4th. And so 1/8 times 2 to the 4th is going to end up to be 2. 1/8 times 1 to the 4th is going to be 1/8. And if I do 2 minus 1/8, that is 16/8 minus 1/8, 15/8. Now, if you do like plugging the variable, the x squared plus 1 back in, think about what this would be. Instead of 1/8 u to the 4th, you would have 1/8 x squared plus 1 to the 4th. But because our variable is x, I would go back to my x limits, which would be 0 and 1. So now I plug in those. So 1/8 times 1 squared plus 1 to the 4th minus 1/8 times 0 squared plus 1 to the 4th. And sure enough, you get the same thing. 1/8 times 2 to the 4th minus 1/8 times 1 to the 4th. So it's really the same line as what we had right here. And again, that ends up to be 2 minus 1/8, which is 15/8. So it's just a preference which one you like to do. This one seems to have a little bit less as far as steps go. But if you are used to plugging back in for x, that's fine. Just make sure you put your limits back to x limits. So again, you don't have to do both of these for every single problem. Pick a way and go with it. Just make sure that if your variable is x, you're using your x limits, and if your variable is u, you're using your u limits. So let's go to our second example. And if you want to try this now, this will be a good time to pause. Okay, so looking at number 2, choosing my u, I'm going to choose the 2x minus 1. And obviously the derivative of that's 2 is not in the problem. I still have this x in the problem. So this will be a u sub back sub. And I need to solve for x. So I'm going to add 1, divide by 2, and then I'm going to take my derivative. So the derivative of 1/2 u is 1/2 du dx. Derivative of 1/2 is 0. Derivative of x is 1. And so I am going to multiply by the dx. 1/2 du is going to be equal to dx. So I'm going to replace my dx with 1/2 du. So that replaces the dx. And then I chose my u as this bottom part that was underneath of the square root. And again, it was on the bottom of the fraction. So that's technically a u to the negative 1/2. And then I still have this x that I haven't accounted for, so I have to come over here and remember that x is equal to this 1/2 u plus 1/2. So I'm going to put that in parentheses, and I have everything accounted for now. I need to distribute through. So when I add the exponents, I have negative 1/2 and 1, which will be positive 1/2. And then here I just multiply by 1/2, so I don't have to worry about adding exponents. And I'm ready to go to my next step. And since I prefer keeping everything in terms of u, I want to make sure I have my u limits, which I haven't done those yet, but I'm just going to do it the one way this time. I'm going to do it the u way. So let's go back and think about our u limits. I'm still plugging in up here where I know what u is to get those u limits. So plugging my x limits in, getting u's out. So 1, plug in 1. 2 times 1 is 2, minus 1 is 1. So I still get a 1 there. And then 5. 2 times 5 is 10, minus 1 is 9. And so my u limits are 1 to 9. And again, x limits with the x variable, u limits with the u. So I'm going to bring down the 1/2 from the outside. I'm going to take my antiderivative, so that would be u to the 3/2. I still have the 1/2, but if I flip and multiply, I get 2/3. And I'll simplify in just a moment. And then here I'm going to bring down that 1/2. Add 1 here, I get 1/2, flip and multiply. And I'm evaluating from 1 to 9, but I'm going to simplify first. So I have 1/2, and my 2's will cancel, so I'm going to have 1/3 u to the 3/2. And then the 2's cancel here, so I just have 1 times u to the 1/2. And evaluating from 1 to 9. I'm going to do one more step before I start evaluating, and that's multiply by that 1/2, because I just don't want to have a ton of things out here. So 1/2 times 1/3 is 1/6. I have 1/6 u to the 3/2 plus 1/2 u to the 1/2. And again, evaluating with my u limits 1 to 9. Okay, so now I'm simplified enough for myself, and I'm going to go ahead and plug in the 9 and the 1. So when I plug in the 9, I have 1/6 times 9 to the 3/2 plus 1/2 times 9 to the 1/2. And then I'm subtracting, plugging in the 1. So 1/6 times 1 to the 3/2 plus 1/2 times 1 to the 1/2. Okay, so now let's do the math. 9 to the 3 halves would be the square root of 9 cubed. So the square root of 9 is 3, 3 cubed is 27. So I have 27 over 6 plus square root of 9 is 3. 3 times 1 half is 3 halves. And then over here, 1 to any power is 1, so I have 1/6 plus 1 half. And I'm out of room, so I'm going to go ahead and tell you this first set of parentheses comes out to be a 6. The second set comes out to be a 2/3. And again, I had to do common denominators to get all that. And so I end up with 16/3 as my final answer. But again, the key point of this lesson is to make sure that when you change to u's, you also change the limits, and that you do have the two options like we discussed in problem 1, where you can either keep your u and your u limits or plug back in for x and go with your x limits. Either way, you get the same answer. It's just a personal preference, however you like to do it. So just make sure that when you do change to u, you change your u limits in your work so that you can get credit for that. That concludes this lesson.